Welcome to CSEGuru. Next topic we will discuss is Floyd's algorithm. This Floyd's algorithm is used to find the shortest distance from each node to all other nodes in the given graph. This Floyd's algorithm is commonly called all-pair shortest path problem since it is used to find the shortest path from every node to all other nodes in the given graph. And this Warshall's algorithm, if you are considering, it is used to find whether there is a path from each vertex to all other vertex in the given graph. But Floyd's algorithm is used to find the shortest distance from each vertex to all other vertex in the given graph. This is the difference between Floyd's and Warshall's algorithm. So, this Floyd's algorithm, if you are considering, it is a modified version of Warshall's algorithm. And if you are considering this example graph, consider each vertex, that is A, B, C and D. So, for each vertex, what is the shortest distance from A to B? And then shortest distance from A to C and then A to D. Similarly, B to A, what is the shortest distance? B to C and B to D. Likewise, we need to find the shortest path from each vertex to all other vertex in the given graph. And in this Warshall's algorithm, it will find whether there is an existence of path between each pair of vertex in the given graph. Since this Floyd's algorithm, it is a modified version of Warshall's algorithm, we can commonly call this Floyd's algorithm as Floyd Warshall's algorithm. Now, we will discuss an example to implement this Floyd Warshall's algorithm. So, this is the given graph. So, here we need to find the shortest path for all pair of vertices in the given graph. So, first we need to find the cost matrix for this given graph. So, cost matrix is nothing but for A to B, what is the cost we need to implement, and A to D, what is the cost, A to C, what is the cost. Likewise, we need to consider and we need to fill this matrix. And if you are considering for A to A, since we are not going to find the shortest path for one vertex to itself, A to A, B to B, C to C and D to D, these diagonal values we need to make it as 0. Since we are not going to find the shortest path from the vertex to itself. So, A to A, the value is 0. And A to B, if you are considering, there is no path, there is no direct path. We don't know the distance also. So, we will make it as infinite. A to C, if you are considering, the cost is 3. And A to D, if you are considering, we don't know the direct distance. So, we will make it as infinite. And B to A, the cost is 2. And B to C, we don't know the distance. We will make it as infinite. And B to D also, we don't know. We will make it as infinite. And C to A, there is no direct path. Only there is a path from A to C. So, we will make it as infinite. C to B, the distance is 7. And C to D, distance is 1. Next, D to A, the distance is 6. And D to B, there is no direct path. So, we don't know the distance. We will make it as infinite. And D to C also, we don't know the distance. So, we will make it as infinite. So, this is the cost matrix for this given graph. So, with the help of this cost matrix, we will consider each vertex, that is a path through each vertex, and we will find the shortest path. Step 1. Consider the shortest path through vertex A. So, through the vertex A, what is the shortest path to all other vertices we need to find? So, with the help of this cost matrix, we need to consider the shortest path from A, and we will find the new matrix. So, the new matrix, we will consider it as R of 1. And in this new matrix, we are not going to disturb the diagonal values. That is, we are not going to find the shortest path from the vertex to itself. That is A to A, B to B, C to C, D to D, likewise. So, these positions always the value is 0. And the remaining positions only we are going to find. And here we should not disturb A row values and A column values, since we are considering the shortest path through the vertex A. And the remaining positions only we need to consider. So these values we can write as it is. That is infinite, 3, this is also infinite. And 2, infinite, 6. Next, we need to consider B to C. This distance we don't know, and we are considering the path through vertex A. That is the shortest path through vertex A. So, consider the shortest path B, C. What is the minimum value we need to find? So, we need to consider the logic minimum of the distance B to C. So, B to C, it is infinite only. Comma, since we are considering the shortest path through A. So, B to C, in between, we need to implement the vertex A. That is, B to A plus A to C. So, what is the minimum value we need to consider? And here, if you are considering, this is minimum of B to C is infinite. And B to A, if you are considering, it is 2. Plus A to C, if you are considering, it is 3. So, we will get it as 5. The distance, we will get it as 5, shortest distance. Likewise, we need to find for all other values. Next is B, D. We need to find the shortest distance. B, D. That is minimum of B to D, in between we need to consider vertex A. That is B to A plus A to D. B to D, the value is infinite, B to A. B to A value is 2 plus A to D value is infinite. So, we will get it as infinite only. We won't get the shortest path through the vertex A. Next, we need to consider C to B. C, B if we are considering, that is minimum of C to B, we need to consider through A. So, C to A plus A to B, whether there is a path, shortest path. So, we will get it minimum of C to B is value is 7, C to A is infinite and A to B is also infinite. That is infinite plus infinite. So, we will get it as 7 only. Next, we need to find the shortest path for C to D. C to D, if you are considering, that is minimum of C to D, through vertex A we need to consider. So, C to A plus A to D. So, we will get it as minimum of C to D, if you are considering, the distance is 1. And C to A infinite and A to D is also infinite. So, we will get it as 1 only. Similarly for D to B and D to C. So, this value is 1. So, minimum of D to B is infinite. D to A plus A to B. D to A is 6 and A to B is infinite. So, 6 plus infinite. So, we will get it as infinite only. So, here we need to fill infinite only. Next, D to C we need to find. So, minimum of D to C is infinite, D to A and A to C. D to A is 6 and A to C is 3. So, 6 plus 3, 9 we will get. So, the distance we will get it as 9. So, this is the new matrix we have found through the vertex A. That is the shortest path through the vertex A. Next step, we need to consider the shortest path through the vertex B. So, step 2, consider the shortest path through the vertex B. And we are going to find the new matrix R of 2. Since we are considering the shortest path through B, we need to neglect this B row and B column. And the remaining places, wherever values are there, we need to find, except the cycles, that is A to A, B to B, C to C and D to D. Keep the values of B row and B column as it is. and also the diagonal values, since we won't find the shortest path for the diagonals, that is the vertices 2 itself. And the remaining positions we need to find the shortest path. So we need to find shortest path for A to C first. So we need to consider minimum of A to C, comma, through vertex B. So we need to consider A to B plus B to C. A to C, if you are considering, the distance is 3 already. And A to B is infinite plus B to C is 5. So we will get it as 3 only. Next is A to D, shortest path for A to D. So we will get it as minimum of A to D through the vertex B we need to consider. That is A to B plus B to D. So we will get it as minimum of A to D, value is infinite, and A to B is infinite, plus B to D is also infinite. So we will get it as infinite only. Next is C to A. Shortest path for C to A. That is minimum of C to A, comma, through the vertex B. So C to B, B to A. C to B plus B to A. So we will get it as C to A is infinite, and C to B 7, B to A is 2. So 7 plus 2, we will get it as 9. Next C to D we need to find. Minimum of C to D, comma, through the vertex B. So C to B, B to D. C to B plus B to D. So we will get it as C to D is already 1. C to B, if you are considering, it is 7, and B to D, it is infinite. So the minimum distance we will get it as 1 only. Next is D to A. Minimum of D to A. We need to consider the path through DB. So D to B plus B to A. So we will get it as D to A is 6. And D to B is infinite. B to A is 2. So infinite plus 2. That's infinite only. Next, we need to find the shortest path for D to C. Minimum of D to C, comma, D to B plus B to C. So we will get it as minimum of D to C is already it is 9. And D to B is infinite. B to C is 5. So we will get it as 9 only. There is no change in this row. So this is a new matrix we have found by considering the shortest path through the vertex B. Next, step 3. Consider the shortest path through vertex C. Since we are considering the shortest path through vertex C, we should not disturb C row and C column values. We need to consider as it is. And the new matrix what we are going to find is R of 3. And here C row and C column values we need to write as it is. And the diagonal values also we should not disturb. In the remaining positions, we need to find the shortest path. That is A to B. So A to B, if you are considering, that is minimum of A to B, comma, through the vertex C. So A to C plus C to D, whether there is a shortest path. So we will get it as minimum of already A to B, the value is infinite. And A to C, if you are considering, value is 3 plus, so the distance we will get it as 10. Next is A to D. So A to D, A to D. Minimum of A to D, and we need to consider the shortest path through C. So A to C plus C to D. So we will get it as A to D is infinite, comma, A to C is 3 and C to D is 1. The distance we will get it as 4. And next is B to A. Minimum of B to A, comma, B to C. Shortest distance we need to consider through C. B to C, C to A. B to A is value is 2. And B to C is 5. C to A is 9. So which one is minimum? 2 is minimum. So we will get it as 2 only. Next we need to find shortest distance for B to D. Minimum of B to D, comma, we need to consider the shortest path through C. So B to C plus C to D. B to D, the value is infinite. And B to C value is 5 plus C to D value is 1. So we will get it as 6. Next we need to consider shortest distance for D to A and D to B. Minimum of D to A and D to C plus C to A. D to A is already value is 6. D to C is 9 plus C to A is 9. So which one is minimum? 6 is minimum. Next shortest distance for D to B. So we will get it as minimum of D to B, comma, through the shortest path C. D to C plus C to B. So we will get it as D to C is already the distance is 9, and through C if we are considering D to B is infinite, and distance if we are considering through C, D to C is 9 plus C to B is 7. So we will get it as 16. So R of 3 is the new matrix we have found out by considering the shortest path through C. Next is step 4. Consider the shortest path through vertex D. Since we are considering the shortest path through the vertex D, we should not disturb the values in D row and D column. The remaining values we need to consider and find the shortest path through the vertex D. And the new matrix what we are going to find is R of 4. And the D row values and column values as it is we can keep. And the diagonal values 0 only. So we need to find the shortest path for A to B. So A to B if you are considering it is minimum of A to B, comma, through the vertex D. So A to D plus D to B. So we will get it as A to B already the value is 10. And A to D value is 4 plus D to B value is 16. So which one is minimum? 10 is minimum. Next, A to C. So we will get it as minimum of A to C through the vertex D. So A to D plus D to C. A to C is the value is already 3. A to D is 4 plus D to C is 9. So which one is minimum? 3 is minimum. Next, B to A. Minimum of B to A, comma, B to D plus D to A. Since we are considering the shortest path through D. B to A value is already 2. And B to D value is 6. D to A 6. So 2 is minimum. Next, B to C. Minimum of B to C, comma, B to D plus D to C. B to C is value is already 5. And B to D is 6. D to C is 9. 6 plus 9. So the minimum we will get it as 5 only. Next, C to A. Minimum of C to A, comma, C to D plus D to A. So C to A is value is already 9. C to D is 1 and D to A is 6. So 6 plus 1, minimum value we will get it as 7. Next, C to B. Through the vertex D. So C to D, D to B. So C to B already the value is 7. C to D value is 1 and D to B value is 16. So 1 plus 16. So the minimum value we will get it as 7 only. So this is the final matrix. Since we have considered the shortest path through vertex A, B, C and D. So these four vertices are the given vertices in the graph, and we have considered the shortest path through each vertex. So this is the final matrix we will get it for the shortest distance from each vertex to all other vertices in the given graph. And if you are considering manually here, A to B, what is the shortest path? A to B, there is no direct path. So we need to consider A to C and C to B. So the distance we will get it as 3 plus 7, 10. And A to C, if you are considering, there is a direct path, that is 3. And A to D, if you are considering, that is A to C and C to D. So 3 plus 1, that is 4. Next, if you are considering vertex B, the shortest path from B to A is 2. And B to C, if you are considering, there is no direct path. We need to consider through vertex A. So B to A and A to C, the distance is 5. And D, if you are considering, there is no direct path. We need to consider through A and C. So B to A to C and C to D. So 2 plus 3 plus 1. So we will get it as 6. Similarly, for vertex C, if you are considering C to A, there is no direct path. We need to consider through either through D or through B. So C to A, if you are considering, C to B and B to A, it is 9. And C to D and D to A, it is 7. So this is the shortest path. So here we got it 7 only. In C to B, if you are considering, it's a direct path, the distance is 7. And C to D, if you are considering, direct path, distance is 1. And D to A, if you are considering, there is a direct path, distance is 6. And D to B, if you are considering, it's an indirect path, the distance, if you are considering, D to A to C and C to B. So D to A, 6 plus A to C is 3 and C to B is 7. So we will get it as 16. And D to C, if you are considering, that is D to A and A to C. So distance is 9. So likewise we need to consider. So manually also, if you are considering, we are getting the same shortest distance. And this Floyd's algorithm is also used to find the all pair shortest path problem. That is, from each vertex to all other vertices in the given graph, it will find the shortest path. But Dijistra's algorithm already we have discussed. So Dijistra's algorithm is used to find the shortest path from single source to all other vertices. But this Floyd's algorithm is used to find the shortest path from each vertex to all other vertices. So this is the difference between Dijistra's algorithm and Floyd's algorithm. And difference between Floyd's algorithm and Warshall's algorithm is, Warshall's algorithm, it will check whether there is an existence of path from each vertex to all other vertices. But Floyd's algorithm is used to find the distance, shortest distance from each vertex to all other vertices. So now you will better understand the Floyd's algorithm, Warshall's algorithm as well as Dijistra's algorithm. The Warshall's algorithm and Dijistra's algorithm, I will provide the link in the description for your reference. In the next session also, we will discuss one more example to implement Floyd's algorithm. And this Floyd's algorithm, commonly we will tell it as Floyd Warshall's algorithm only, since this is an improved version of Warshall's algorithm. Thank you for watching this video.